everything that we've talked about so far, so this includes RAG and agents and LLMs, they need hardware to run. Without hardware, there's no way to power them. And that's why we're going to talk about scaling AI in this week, part 4. So we've covered how AI works, how to use it, and how to build with it. And now we're going to look at how it runs. And this is a layer which most people never even think about, but it's what determines the cost of these AI models and how fast they run. So throughout the course, I've mentioned the term GPU or hardware a few times, but you probably don't even know what it is and why AI specifically needs GPUs. So your computer has a CPU, a central processing unit, and it's brilliant at doing one thing really fast, like opening a spreadsheet, running a calculation, switching browsers, and loading a page. One task, then the next, and then the next. But AI doesn't work like that. It doesn't do things one at a time. When a transformer processes your prompt, it's doing millions of multiplications of vectors simultaneously. And every attention head, every layer, every token, all at once. A CPU doing that would take forever because it would do everything one by one. And the GPU is important because it's a graphical processing unit that does thousands of operations in parallel. And it was designed for rendering video game graphics, and video game graphics are very similar in nature to LLMs working. They take in millions of pixels, and those need to be calculated at the same time. So it turns out that the math for rendering video games is similar for the math for running machine learning and language models and things like that. The thing is that one company figured out how to take the power of GPUs and use them on AI before everyone else, and this company is NVIDIA. In 2020, they released the A100. This became the standard chip for AI training, and every major AI lab was buying these from NVIDIA. And then in 2023, the H100 came out, which was 2 to 3 times faster than the A100. It was about $30,000 per chip. When ChatGPT blew up, these became the most sought after pieces of hardware. And there were literally waiting lists so that people could acquire them. And not normal people could acquire this, of course, because they're so expensive. And companies were spending billions of dollars to secure a supply of these H100s. Then you fast forward to 2024, and the B200 came out, the Blackwell. It's double the H100 performance. NVIDIA controls about 80% of the AI chip market. AMD and Google are competing, but NVIDIA's CUDA software system is so popular and sought after, and it helps reduce the cost when running these AI models. So when people are talking about the AI boom, NVIDIA is one of the companies that made this possible because all of the companies were wanting these GPUs because of how powerful they are. So NVIDIA makes these GPUs, but as I said before, normal people like us can't really afford them because they're $30,000 and up. But big companies can afford them, and then we can access them through the cloud. And the cloud is run by a handful of companies that are called hyperscalers. Some popular hyperscalers that buy GPUs from NVIDIA are AWS, which is Amazon, Azure, which is Microsoft, Google Cloud, and Oracle Cloud. Right now, AWS is the largest cloud provider, and their AI platform is called Bedrock, and it gives you managed access to Claude, Llama, and other models, but you don't have to handle the infrastructure yourself. And SageMaker is their machine learning platform for building and training machine learning models. And they also make their own AI chips because they're trying to reduce their dependence on NVIDIA, but of course NVIDIA is the one that's most sought after. Next is Azure Microsoft. This is the OpenAI cloud. Microsoft invested billions into OpenAI and hosts all the GPT models on Azure. So if your company uses Microsoft, Azure AI Studio is usually the path that your company would take. And it's also tightly integrated with Microsoft applications like Teams, Office 365, and things like that. Next is Google Cloud. Google makes their own chips called TPUs, tensor processing units, and they offer these too. And they're designed specifically for AI. And they also have standard NVIDIA GPUs too. Their platform is called Vertex AI, and Gemini runs here natively. Then Oracle Cloud, it's not like the other big three. It's kind of like a surprise player. It's growing fast in AI infrastructure and is partnered with multiple AI companies. Competitive pricing is pulling customers who don't want to be locked into one of these 3 expensive and well-known hyperscalers. But here's the big picture. Without hyperscalers, AI would only be accessible to the richest people on the planet. And running a single training run for a model would require thousands of GPUs running for months, and normal people can't afford that. But the cloud is what allows normal people like us to get access. Anyone who can pay a little bit of money to have a GPU running can build their own AI applications without relying on APIs, because APIs are not sustainable for real world apps, and you have to start using cloud and self-hosting your models with hyperscalers. NVIDIA's CEO has a framework that can help you understand the AI industry. It's 5 layers, and each one depends on the one below it. So let's start with the top layer, layer 5. Let's go backwards. All applications such as ChatGPT, Claude.ai, and Copilot, users are able to interact with it. But applications won't be made possible without models underneath it. Like when you're talking to Claude, there's obviously going to be a model in the backend. If you're talking to ChatGPT, there's going to be a GPT model in the backend. But these models can't run without infrastructure. And infrastructure can be provided through cloud data centers, or you can buy your own GPUs if you're a huge company. And infrastructure needs to be maintained. But infrastructure can't run without GPU chips, like the H100, the B200, and things like that. And chips cannot run without electricity. And running AI infrastructure requires a massive amount of electricity. Why do these layers even matter? Well, it tells you where the power is, and us as developers, we're usually on layers 4 and 5, where we're using our own models and we're building applications with these models. But the companies that control layers 1 through 3, like NVIDIA, hyperscalers, energy companies, they're the ones that's allowing AI to be possible. And you can't build any AI applications without the infrastructure, chips, and energy. Now you understand why scaling AI is so important. We can't build AI applications without the underlying infrastructure, which is why it's important to use things like hyperscalers. And these give us access to GPUs that run AI models. Now you understand what GPUs are, but just because these companies have control over the GPUs doesn't mean that we can't control them in some way too. We have to do a lot of work to make sure that these GPUs are aligned with what we need when we're building our applications. That's what this part 4 is about. And I'll see you in the next video where you'll learn more about this.